This is A-level maths, pure paper 1 from 2022. So the first question then about transformations. Draw this point down. It's at -2, -5. So it's 2 to the left, 5 down. This transformation moves everything up by 2 places. So if this goes up by 2 places, this coordinate, the x-coordinate, doesn't do anything. This one goes up by 2 to become a -3. This transformation here takes any part of the graph that's below the x-axis and puts it above the x-axis. So for example, this one here, these two bits don't change, but this bit goes over the axis like this. And look here, this point 1 -4, that became a 1 +4. So the x-coordinate stays the same as it reflects upwards, that's still a -2. This becomes a +5. This is a movement to the right by 2 places. Remember, it goes right if you take away. Then stretch 3 up and down, so vertical stretch, then move up by 2. So let's move it right 2 places first. That gets into there. So this coordinate goes to a 0. This doesn't change. Then we stretch factor 3 up and down. So this stretches down to -15. 0 stays the same. And then you move it up 2 places, and you get to 0 -13. And that would be our answer there. Question 2 then. So if that's a factor of that, that means whatever x needs to be to make this 0, which is -2, f of -2 is 0. That's just what factor theorem says. So do have that in mind, because it will be asked in your papers. So f of -2, just replace all these with -2s. Remember, -2 squared is +4. These two negatives make a positive as well. And f of -2 is 0, as we've said. That's what factor theorem does. And then, of course, this is just something we can solve nice and slowly for k, and we'll eventually end up with k is -17. Question 3 then. So if you want to, you can swap these two bits over first. That way you can complete the square on this bit nice and easily here, and then on this bit separately. So here, halve the 10 for a -5, take away 5 squared, halve the 16 for an 8, take away 8 squared, and then move the 25 and the 64 over to here to make this. This is 13 squared, which is nice because that gives you 13 as r, and that gives you the center. Swap these signs over is 5 -8. Now for this one, given point P is this point in the circle furthest away from the origin. Now if you're ever in doubt about a question, just draw it. So here's a drawing, center 5 -8, so down here somewhere. And the circle goes around here. I know it goes through the origin like this because if you measure, or if you work out the distance from the origin to the center, that's just 5 squared plus 8 squared square rooted, just because it's 5 across 8 down. That should really go to the center, but whatever. And this makes roots 89. And then you can just see that the point furthest away from the origin will just be in a nice straight line through the center all the way to the other side of the circle. And this distance here is just 13. That's the radius of the circle. So the total largest distance from the origin is just root 89 plus 13. This should all be in a nice straight line, but just demonstrating here that your picture can be pretty terrible as long as you have a vague sense of what you're doing, and everything will be fine. Question number 4. This is the definition of an integral. When you sum up lots of things, and the sums are getting thinner and thinner. So this is just the integral between 2.1 and 6.3 of 2 over x dx. So that's kind of cool. Hence show this thing here. So obviously we just replace this with that. So we integrate it. The integral of 2 over x is 2 log x between here and here. Put those two numbers in. At this point you can do power laws with logs. You can move this 2 up to here and this 2 up to there and get this. And then you can do the subtraction rule, whereby if you're doing log something minus log something else, you can do log of this divided by this. And then you can type that bit into a calculator if you want to, and you can see that it's going to be 9. Good. Question 5 then. So the height of the tree is this. So h is 2.6 when t is 2. Let's just shove that in there, and we get this. And here, h is 5.1 when t is 10. So let's shove those results in there. We get this. This is a simultaneous equation. You could do this straight in a calculator, or you could do this one minus this one to get this. And then you could divide by 8 to get this, and then you could put that result into here, and we'll eventually end up with this. And so the thing is going to be of this form here. Given the height is 7, exactly 20 years after being plotted, evaluate the model. So let's put 20 years into the model and work out the height. We eventually end up with this, which is pretty close to 7 meters, so I think it's a pretty decent model, and we'll just say that. Question 6 then, so we've got a curve here, maximum at 2 is 8. It's got a repeated root, which will come in handy later at 6. And it's a positive cubic, so that's kind of quite cool. Write down the set of values for which f dashed of x is less than 0. F dashed of x is the gradient. So which values here is the gradient negative? Well, it's negative here, right? When it would follow a line that goes in this direction. So the gradient of this curve is negative between 2 and 6, I think, is all we have to say. The line with equation y equals k. So y equals k is a horizontal line. So if I just put it randomly like here, pretend this k is like 20, whatever. If we put it here, it has one solution with the cubic, it has one intersection. which is actually what we're looking for. But where else could we be to give this horizontal line one intersection? And maybe just draw it down in your mind and think, okay, where are all the points? Where are all the points where you get one intersection? Well, right at the top you did. And then there was a point in the middle there where you didn't. Like right now you have 3 of them. And then down here you do again. So I think as long as you're sort of above this point 8, as long as you're above 8, you have one intersection up here. And as long as you're also below this 6, sorry, not below 6, but below the x-axis, you also only have one solution. So I think either k is bigger than 8 or k is less than 0 will do this. In set notation, that looks a bit like this. When you've got two areas that don't, that you can't write in one inequality like k between two things, you have to use this union symbol like this here. Find the equation of c. So it goes through 0, 0, so it has a root at 0, and it also has a repeated root at 6. So we can write it like this. However, this doesn't quite work, because if you substitute in 2, 8, x is 2, y is 8, this doesn't work. 2 minus 6 is minus 4, squared is 16, times 2 is 32, that doesn't work at all. So what you have to do is put in a scale factor, which we'll call a for now, and then substitute 2, 8 to figure out what that a value is, and you get a as a quarter, and so that will be the answer there. But it has to go through here, because that's on the curve, so it has to obey that point there. And we'll get this here, and that will be an acceptable answer. So 7 then, so we'll set up our contradiction. So let's assume P and Q are odd, and that PQ is even. If P and Q are odd, we can write them like this. This is just from GCSE maths, if you remember. And then we can just times PQ together and see what happens. Let's times this and this together. We get this, we expand out, we factorize out 2 from the first 2, and this is clearly an odd number, because it's 2 times something plus 1. So this is odd, and so by contradiction, one of P or Q at least must be even for this to work. Given this stuff, show this. So given this, so we're allowed to start here. So let's start here. Let's expand it out. So this is x plus y times x plus y. So it's x squared plus xy plus xy plus y squared, which is this. Some stuff cancels, and you can simplify to this, I guess. This cancels, and then take away short. Now, x is less than 0. So if you divide both sides by x here, this sign is actually going to flip over. Just to explain, of course, I think we can probably all agree with this statement here. If we divide by minus 1, we get this, which isn't correct, right? You need to flip the sign if you multiply or divide by a negative. So we'll flip the sign here if we multiply or divide by a negative, which we are. We're dividing by a negative number here. So we'll end up with this, and then divide by 2, and we end up with what they wanted us to get. 8 then, so I thought this was a surprisingly hard question for only halfway through the paper. Just this bit I thought was really interesting. Find the value of t first. Well, t is the last time here, and we can see that v is 0 when we get to here. So we put in v as 0. Now this can't be 0. Log of nothing will be 0 unless you want to play around with some limits, but we won't do that. So let's just do this equals 0. And solve for t, we get t as this. Now show the maximum speed occurs when this is true. Now this, I think, is the hardest 4 marks in the paper. Firstly, we find dv by dt, right? Because we're looking for maximum speed, so this is dv by dt equals 0. So I first expanded this out just because I don't really know. I don't think it was a good idea. But I expanded it out, and then I differentiated. Now, this just differentiates. Logs differentiate to the thing inside the log on the bottom, and then the differential of this thing on the top. Now, the differential of this is just 1. So it's just 10 times 1, which is 10. And now this is a product rule, because it's got a t there and a t in here. So differentiate this t to just get 1, and leave this alone. And then leave this t alone and differentiate this, which looks exactly like the same as when we differentiate this here. Now I can put these two fractions together to make this. And like I said, dv by dt needs to be 0 for a maximum, to find a maximum. And now we can force move this to the other side. And now what I did was times everything by t plus 1, and I expanded this out. I need to go to another page, so apologies for that, but go to another page. Expand this out. We get this, I believe. I'm going to put this 0.4t over here and this over there to get this. Then I'm going to factorize out t here from these two terms, and then divide this through. I'm sure there was probably a better way of doing this. And now I'm going to go, I think I'm going to times everything by 2.5. Yes, what a legend. So times everything by 2.5 just to get some nice numbers. And now here you need to go full black pen, red pen. You need to notice there's a 25 here, and they've got a 26. So what we're going to do is we're going to add 1 to this numerator, only to take 1 away immediately. I think that makes sense, because now we have a 26 here, and then we have a minus, and then we could factorize a bracket here to make 1 plus log t plus 1. I think this all works. And then, of course, we can split this fraction down the middle here to get 26 over this, minus this over this. But this over this is just 1. So we get this over this minus 1, which is what they want us to get. I think that was a brutal question to shove in halfway through, but whatever. We get some nice 3 marks here, though, nice and easy. We start with n is 1 to get t2 equals, and then you just put 7 into here. You press equals in the calculator. I don't care what the answer is. You just edit the calculator to say ands in it instead, and then you press equals again, and you get this. By repeated iteration, show the maximum speed. At this point, you've still got this in your calculator. You just press equals about 10 times or more, just until you get bored, and eventually you end up with a number that just stops changing at all, and it's this number here, and I just decided to write out the whole thing because I was bored. The next one is a vectors question. Again, I mentioned this question was hard. They then shoved in another really hard question straight after it. This bit at the end here. Anyway, PQ is this. I'm going to write this as columns. Now, PQ is parallel to RS. So if PQ is this vector, so is RS. And also QR is parallel to QS. So if QR is this vector, so is PS. And I know that because it's a parallelogram. So these vectors are all like this. Now, the length of this vector here is root 2 squared plus 3 squared plus 4 squared, which is this. And the length of this vector here is root 5 squared plus 2 squared plus 0 squared, I guess, which is that. And now, because it's a parallelogram, and because all 4 sides are the same, that makes it a rhombus. And explain that as clear as you can. The general rule of thumb in this video is explain things more clearly than I am, because I'm saying stuff out loud, whereas you can't do that in your exam. So just write down some of the things that I'm also saying. Now, next, find the exact area of this. If you are doing further maths, specifically FP1, then you'll know the absolute best way of doing this question, which is to do the cross product between these 2 vectors, and you'll get the question done in about 30 seconds. If you're just doing core pure 1 and 2, you'll know that you could do the dot product between these to find an angle, and then you could apply that angle to half AB sine C or whatever. It's much more difficult for people who don't know those things. Okay, how do we do this? Well, the first thing we'll do is consider P to R, which is just this vector plus this vector. So that's 7, 3, minus 6. And we can work out the length of this very easily. It's root 7 squared plus 3 squared plus 6 squared. It's technically minus 6, but that squares the same thing, so it doesn't matter, which is this. So that's the length of this. Now, from here, what you could do is you could think about this triangle and do cosine rule, because you have this length, and this length. You could do cosine rule to find cos of theta, and therefore find theta, theta being this angle here. The problem with that is they want an exact area. So if you got cos theta and then just did cos inverse, you'd get an angle to some decimal. And then when you try to do half AB sine C, you'd end up with a rounded answer and it wouldn't be exact. Now, you can get away with that by working out what cos theta is using cosine rule, and then using cos squared equals 1 minus sine squared and finding sine exactly, and then applying half AB sine C. That's not, you could do that. I'm just saying you could do that. You could also, by the way, apply Heron's formula, which I've talked about in videos before, just because now you have these 3 sides, so you could just immediately apply Heron's formula. The question will finish in about 20 seconds. If you don't know any of those tricks, I'll do it the way that the mark scheme suggested you do it, which is, let's find S to Q, which is minus this vector plus this vector. So minus 5 plus 2 is minus 3. 0, or minus 0 plus 3 is 3. Minus 2 is 2, minus 4 is minus 2. The length of that is this, just doing some more Pythagoras, which is this. And now, rhombuses, the diagonals of a rhombus intersect at 90 degrees, which is apparently stuff you needed to remember from like year 7. And also, not only that, but the area of a rhombus is, if your diagonals intersect at 90 degrees, that means the area is just this length times this length halved, which when you, of course, put that in a calculator, you immediately get an exact value. And that's the way that they were expecting you to do it. Now, I don't think many people remember that rule, or about the half area thing with the 2 diagonals, because we just don't teach it very much. But that was the way you expect to do it. Again, if you're doing further maths, feel free to do your fancy vector things on questions like this, because it's genuinely easier. And even then, also bear in mind, you could have done cosine rule. If you want to learn Heron's formula, go ahead and learn Heron's formula, because maybe it'll get you out of this situation occasionally as well. But anyway, next question then. So we've got this model here. Find the number of v's at the start. That's when t is 0. T is 0 makes this 1, which makes 45 plus this equal to this. Remember to put the 1,000 at the end, because it's measured in thousands. The answer isn't 265 b's. It's 265,000 b's, I believe. Okay, show that exactly 10 years after the start of the study, the number of b's are increasing at a rate of. Now, a rate of means dn by dt. So we need to work out dn by dt. This differentiates nothing. Bring this 0.05 down to there, which makes an 11, and then that just leaves the same. So e to the power f of x differentiates to f dashed of x, which in this case is just 0.05, e to the f of x. So we just get this. Okay, and then we set t to be 10, and we get this, which we type in the calculator, we get this, which is approximately 18,000. And just like I said, just write stuff down. Just don't assume that they know that you know this is 18,000. Just write stuff down. Anyway, the number of wasps measured in this is given by this. When t equals big T, there are an equal number of bees and wasps. So we need to set this equal to this, and the t becomes a big T for that. Now, how do we solve this? Well, we can take away 10 from both sides, obviously. And now what I'm going to do is I'm going to times everything here by e to the 0.05t. So that obviously just becomes 35 e to the 0.05t. This, when you times it by e to the 0.05t, imagine another e to the 0.05t here. Those add up, right? It's like e to the 7 times e to the 5 add up to make e to the 12. And this added to itself is 0.1t. Similar thing over here, like minus this plus itself becomes a 0, and e to the 0 is 1, so it just goes away. And now here, I can do a fancy substitution maybe. I've written it like this really quickly. But if I let y equal this thing that we've been talking about, that I just don't want to say again, when we square it, if you times that by itself, again, you add up those indices up there, and we get this here. So we can replace that in there, and we get this. And of course, the calculator will solve this for you very quickly. You get these two things. And of course, I'm not looking for y, I'm looking for t. So we put this number back into here. But when you put a negative into here, e to the power of something can't be negative. So that's actually not a solution we'll care about. We'll just set this equal to that. We'll take log of both sides. We'll times both sides by 20, and we'll end up with this answer here, which will be our answer. Question 11 then. So we've got verify the curves in sector x is a half. All you have to do here is set x equal to half into here, which gives you that, and then put x as a half into here, which also gives you that, so that you can verify that they intersect at 0.5, 10.25. The curves intersect again at the point P. Use algebra and show stage working to find the exact value of P. So we actually do now need to set this equal to this, which rearranges to be that. And now what we know about this is that we know this has a solution at x equals a half. That's what we just showed. So that means factor theorem, but the other way around. We know that x minus a half is a factor, because we know if we put a half into here, this would work. It would get us to 0. So that means x minus half is a factor. Now that's not the easiest thing to use, so I'm actually just going to use 2x minus 1, because, you know, you need to use x as a half to make that solve for 0. But you could also use x as a half to make that solve for 0. So this is just as valid a thing to use. And now most of you will just want to plow on with some polynomial division and just do this divided by that to find the remaining quadratic. I'm not going to do that because I hate polynomial division completely irrationally. I'm just going to set up that this cubic can be written as this, because it's a factor, times something else. That's what factors are. They're things you can multiply by something else to make the thing you're looking at. And when I just look at this, you can see you've got a 2x cubed over here. The only way to expand this to get a 2x cubed, to get an x cubed, is if a was 1. 2x times 1x squared is 2x cubed. So a has to be 1. And also, minus 1 times minus 17 is plus 17. So c has to be minus 17. Working out what b is a tiny bit harder, but just look at the x squareds. There's 15 of them over here. Where are you getting x squareds from over here? Well, there's minus 1 of them here and 2b of them there. So 15 from over here equals minus 1 plus 2b, which makes b 8. And then we have our entire factorization is just this, which is the thing you would have got if you had actually done polynomial division with these two things, but I can't be bothered. So now we just have this is equal to 0, and we know x is a half as a solution. What's the solution to this? Well, you just get out a calculator and you get these two. Now we just need to look back at the graph here. We know x is a half as a solution, which is probably here. This number is bigger than a half because that's like nearly 6. So this is like nearly 2. So I think that's this one here, and this one is negative, so it's another solution over here somewhere, which we don't care about. So therefore, this is the x-coordinate of P, I believe, and we'll be done. Question 12 then is just some integration. It's integration by parts. Now, I do integration by parts, I think, differently to most people. I don't bother with the whole dv's, du's, whatever. I just take one of these ones that I fancy integrating, which is definitely this one, and I integrate it twice. Or not twice, but I integrate it 2 separate times, like here and here. Then I take the other function and I leave it alone the first time, and then I differentiate the second time, and then I just write a minus integral in the middle with a dx in the end. And this is my setup. This is very nice because that just simplifies to x cubed over 4. And then I can just integrate this, of course, x4 over 16. And now you notice I completely ignore the limits. When I'm doing integration by parts, I'll basically just put the limits in at the end. I'll do the whole thing, then put the limits in. So put in e squared into these. Now e squared to the power 4, multiply the indices, is e to the 8. Log of e squared. Now log and e cancel out, so this just becomes a 2. And then log of 1 is 0, so this just becomes a plus, because minus minus 1 over 16. And we end up with this, and then I guess this is, what, 8 over 16 minus 1 over 16 is 7 over 16, lots of this. And we have our answer there. Question 13 then, I'm actually not going to bother doing this. I'll put a link in the description to a few videos that do that proof. It's something you can watch. It's the same thing every time. Lots of other people will do that better than I can in the middle of a video talking about lots of other things. So just watch them if you're not sure how to do this proof, because I honestly can't be bothered. Next, we'll have this guy saving up for a printer of £64. He saves £10 in week 1, £9.20 in week 2, £8.40 in week 3. So this is an arithmetic series going down by 80 pence every time. So the first time is 10, so we'll say A is 10, and the difference is minus 80, or minus 0.8, I guess, if I'm writing in pounds. So, okay, well, we can just use this formula then. So we know the sum that he needs to get to is 64. We know A, we know D. We don't know N, but that's what we'll solve. So let's times everything by 2 to get rid of this, and then expand out, and we eventually end up with this. I think I divided everything by 8. I did. And then I could put these things together anyway, but I put them together now, times by 10, I guess. And then, yeah, you can just rearrange that line, which apparently I didn't even bother writing down, but definitely write down the line they want you to underneath that. A calculator will do this immediately for you, so no point messing around there. We get this. State how many weeks it takes. Now, both these are positive numbers, and they're both whole numbers, so they both seem equally valid, except n is 10 is definitely the answer. And the reason for that is, what the 16 is doing is, after you reach a certain point, like you can imagine after 12 weeks or whatever, he'll have saved £0.20 that week. And then he takes away another 60 and he's saving like minus 40 pence or whatever. And that doesn't make any sense. And it's because he will be saving negative amounts of money that his total sum will start going down again, and it will get back down to 64 when it was previously above it. And so this 16 is just a ridiculous case of continuing this arithmetic sequence further than it's really applicable, saving up a negative amount of money, and then that negative brings your total amount down again. So 10 is definitely the answer. Write something like that down as clearly as you can, and you'll be okay. Now here then, we need the formula book for the first time. These are the compound angle formulas. We'll set x to be A, and we'll set B to be 60 for this first one. And I think we end up with this, just reading this formula. If there's a minus here, then that means there's a minus there, which is what I've done. And for this one, set A to be x and B to be 30. If there's a minus here, there's a plus there. So that's what I've done. Cos of 60 is a half, sine of 60 is root 3 over 2, cos of 30 is root 3 over 2, sine of 30 is a half. So we put all those in, we expand out this 2. We can collect terms here, right? Just do root 3 plus root 3 over 2 for 3 root 3 over 2. And then 1 sine minus a half sine is just a half sine over here. And then you can cancel out these 2's. I think I've been super lazy again. I have cancel out these 2's. Divide by cos, sine over cos is tan, and then you get tan equals 3 root 3, which is what they wanted. Do not do what I'm doing and just stop at a random point. Write it out and get to the end, otherwise you will lose marks. But anyway, next thing here, now hence or otherwise. Now I'm going to use the hence. There are lots of other ways to do it. Hence means use this thing that we just did. Now how on earth is this going to be useful for this? Well, it's just a case of spotting, I guess. You're trying to force this behavior in here. There's a 2 here, which is good, and then this is just a 1. So it seems like it's sort of got there. How do we turn an x minus 60 into a 2 theta? Well, this substitution will do it, I think. The best way of doing it is just literally to do what I just said out loud. Set 2 theta equal to x minus 60, divide by 2, and you get theta is a half x minus 30. But I think this substitution will do it perfectly, because now 2 theta is just, like I said, x minus 60, and 2 theta plus 30, 2 theta is x minus 60, plus 30, 2 theta plus 30 is 2x minus 30. Sorry, it's single x minus 30. I should have written down some more working, like I've said a few times in this video. But anyway, double that, you get x minus 60. Add another 30, you get x minus 30. I think I've made that clearish. and you end up with the exact thing that we wanted to get. So we know that this has a solution at tan x equals 3 over root 3. You do inverse tan, you get these two numbers. Now, we're only looking between 0 and 180, so why have I written that number down? Well, it's because I found x values there, and we need to put those back into here. And this not only halves the number, but also takes away 30. So it's very likely that I'm going to be able to get down below 180 again with this number here, which we do. It turns out the next number you pick by adding, by the way, I did tan inverse of this to get this, and then I literally just added 180 to get this because tan is just repetitive or periodic every 180. So the next one you'd add another 180, but when you halve that, take away 30, you're still too big, so that one doesn't actually work. But yeah, anyway. Question 15 then, so we're in radians now, so we've got to work out something about the volume first. Now the volume is just this area times the height. Now this area in radians, a sector in radians, is r squared theta over 2. So theta is 0.8, 0.8 over 2 is 0.4, so this is just 0.4 r squared. So the volume of this is 0.4 r squared, which is the area of this sector, times by h. Now, I know the volume is 240. I'm just going to divide, no, what am I going to do? I'm going to, I think I divided by 4 to get 60, and then times by 10 to make a 1 here to get 600, and then divided by r squared to get this here. The reason I'm doing that is because I know, because I've done questions like this before, when I think about the surface area, I'm going to use that. But anyway, so now the arc length of a sector is just r theta, so this is just 0.8 r. And now I've got lots of things to do here for the surface area. I've got two sectors, so that's just two lots of this, which is 0.8 r squared. I've got two rectangles here of RH, one at the front, one at the back there. So that's 2RH or HR. And then I've got a rectangle here of length 0.8r and height h. So that's going to be 0.8 HR. We can add those together. And then RH, is going to be 600 over r squared. I'm doing that because their surface area formula only has r's in it. Of course, these cancel. This makes the number we want, and we end up with that there. Use algebraic differentiation to find the value of r for which s has a stationary point. So let's differentiate this. 2 times that is this. Lower that down. This is 1680 r to the power minus 1. Minus 1 times this makes a minus there. Bring the minus 1 down to a minus 2. And we need to set that to be 0 for a stationary point. Times everything by r squared to make this. Clear that out. Add this, divide by 1.6 cube root, and we get something near this. Prove by further differentiation this is a minimum. So take the derivative you had earlier, which is going to be this here, and differentiate it again. That just differentiates to 1.6. The minus 2 comes down to make that a plus and doubles that, make a minus 3 there. And actually what we can see here is that since r is positive because it's a radius, any positive number you put in here makes this positive because it's a positive number plus, when you do put a positive in here, all you do is flip it over and cube it, which just makes a positive number. So this is positive for any value of r greater than 0. And so d2s by dr squared is positive, which means it's a minimum point. And I mean, the better thing to do there is just substitute r as 10 in and show that you get some positive number. But I mean, sure. Question 16 then is the final question in the paper, I believe. We need to show the area can be represented by this. Now, usually when you find area of a curve, you do the integral of y dx, right? So you put your y, the thing that you've given for y in, which has x's in it, and then you integrate with respect to x. Now, we can't do that here because we've been given y in terms of t. You could try and rearrange this for x and put it in there, but it's going to be a nightmare. So what we do instead is we very cleverly write dx as dx by dt times dt. And then these dt's will cancel and get the same thing. But the reason we do that is because now dx by dt I can just work out very quickly. If I write sine squared t like this, we can just do chain rule. 2 times that is 16. Bring the power down to a 1, and then times by the derivative of this, which is cos t, and we get this. And y is just this, so we can put those this one in here, which is there. This is there in there, and this is a dt. And now I can just integrate something with t's in it with respect to t, which is great. The other thing I need to change, though, is I do need to do the limits. So when x is 4, just put 4 into here. When x is 4, divide by 8, we get this. Square root to get this. And now we're only looking between 0 and pi over 2. Now sine is positive between 0 and pi over 2. It's the bit where the sine graph just goes upwards. So this negative value doesn't matter. Do sine inverse of 1 over root 2, and you just end up with t as pi over 4. We're in radians, of course. So this top part of the integral is just going to be pi over 4. When you put 0 into here, I hope we can see sine of 0 is 0. So we're just going to end up with a bottom limit of 0. Now, I've expanded this out. I've done this times this and this times this. The reason I did that is because I noticed that this second term is exactly what they wanted me to get. Now, this first term is not, so I've got some work to do here. What I thought to do was, I said, okay, this is a double angle formula that comes from the compound formulas that we showed up earlier. It's not in the book, but I would highly recommend that you know this formula here, just because it saves you a lot of time. I can write this 32 sine t cos t as I can take one of the 2's out of this and put it there. So 16 times 2 is still 32. But now I can just replace this with that, which is great because, of course, I'm working in t's here, not x's. But anyway, because this times this is just itself squared. So I'm making some progress. How do I make this into this? Well, there's another formula I'd recommend you remember, which is this one. And I can write this just in terms of sine by replacing cos squared with 1 minus sine squared. So this becomes 1 minus sine squared, which is 1 minus 2 sine squared. And then I can rearrange this to give me, well, firstly, actually, I can say x. If I replace x with 2x, then replacing 2x becomes a 4x. And then I can rearrange. And now, if I've got 16 of these, that will make, times this by 8, 8 minus 8 cos 4x, or 4t in this case, which is exactly what they wanted me to get. And I think I have exactly the integral they want me to do. Now, the reason they wanted me to do that was because this is an integrable form. Of course, this just integrates to 8t. This just cos integrates straight to sine, and then you divide by 4 to get a 2. And you can, of course, derive these things to make sure they work. So the differential of this is 4 times 2 is 8, and then sine differentiates to cos. So that's fine. Now, this one's the hardest one to spot. But they gave you a little bit of help up here, I guess, because we did something similar up here. And I guess it's the last question, so it's supposed to be quite tough. But this differentiates to the correct thing. And that's sometimes why integrals are called antiderivatives, because sometimes you're really more looking for something that can derive to it rather than integrating it itself. But this works because, of course, you bring the 3 down to make a 48. This goes down to a 2, and sine t squared is just written like this. And then by chain rule, the derivative of this is cos t, which is there. So sometimes, I think is it called reverse chain rule when you try and notice things of the form f of x, f dashed of x? It doesn't matter whether f of x is to some power, because then you can just do this kind of thing. But anyway, this is the antiderivative, or the integral. You put in pi over 4 to make, well, sine of 4 times pi over 4 is just sine of pi, which goes away, that's 0. Sine of pi over 4 is 1 over root 2, as we saw earlier. Cubed is 1 over 2 root 2. I mean, you can just do this in the calculator. When you put in zeros nicely, everything just goes away, because sine of 0 is 0, and that's 0. We end up with this here. And I think that's the whole paper. So thanks so much for watching. I'll see you next time.